And we're live. We're live again today, friends. Again, we do this. Should we do that? Like, move it. There we go. I like that. Oh my gosh. Looks just organized. Maybe I should just make my bed, right? Here, let's get all these pillows out of the way. My pajamas out of the way. And my blankets. Hallelujah, I'm free. My Savior rescued me. Hallelujah, I'm free. Hallelujah. There we go. That's much better. That is so much more fun to look at. There we go. Oh. Awesome. I'm just going to go to the bathroom real quick. Okay, and y'all, we're back. Oh, what's up, Kira? It's good to have you here. Welcome to my live stream. I think you're the only one watching. How are you doing? Are you doing good? Having a good day so far? You know, we've been planning this this event on the group chat. I don't know if you've seen. Oh, cool. What's up, Kira? Well, today's live stream, we are going to be doing some math because we aren't done yet. Let's see, let's create a new whiteboard. I don't want to do this, guys. I don't want to do this. Oh. Do I have to? Okay, let's see, calculus. What is this called? This is calculus with parametric curves. I don't even know what I'm talking about here. There we go. Let's do this. Thanks, Kira. Thank you. Here. Let's put some books. What? No. Oops. Books. There we go. There we go. Cool. Well, I hope you have a good day, a good rest of your day, Kira. But I'm just going to share my screen. Here we go. To another. Wait, is it considered plagiarism if we record the video? Hold on. I am live streaming. No, I'm live streaming. Watching an ASU provided video. Math 266. Huh. Is this okay? Yeah, I guess that's not okay. Well, in fact, I believe we will stop live streaming. Oh boy. Oh, okay. Hold on. Well, I'm gonna put the phone in silent. Oh, looks like it is already silent. So let's go do this. Oh, I forgot to give our intro. How do you go back? There you go. So, what's up, everyone? Welcome back to our live stream. In today's video, we are going to be doing some more Calculus 2. And yes, I don't have my video shared. I'm not sharing my screen because apparently it'll be considered plagiarism if I show the video I'm watching. But then, of course, I will show the homework I'm doing after that. But we're in module 4. This is the final module of Calculus 2. So we finished the first assignment of module 4. That was parametric curves. I believe the last live stream we did was for module 3, and I did other convergence tests. We finished module 3, and I believe we got in 100 on our quiz. So that was pretty cool. It was not proctored at all, so it was actually much easier. Today we will be doing calculus with parametric curves. Then we have 2 more, polar coordinates, and then areas and length in polar coordinates. And then we have our final exam. And that's all within a week. So we barely have like any time. Yeah. So I believe it is time to begin watching the video for calc with parametric curves. Gotcha. Section 9.2. Okay. Mm. Yep. Yeah. What's the slope of the curve at a point? Okay. What's the length of the curve? Yeah. I'm sorry. What? I guess. Yeah. Hold on. Okay. I'm just gonna go back. Okay. Different point. Y dy dx. The difference in y with what? No, I'm sorry. Yeah, the difference in y over the difference in x. Dy dt. Okay. Okay, got it. Yeah, no, I don't think I have to take any note of this. Oh, differentiating y with respect to t. What the frick are we talking about? Oh, gotcha. Oh my gosh, now we are introducing a third variable, of course. So differentiating y with respect to t. Gotcha. So how does that work? Oh yeah, okay. Well, I guess we'll have to do dy dt since t is what? What's t? Well, t is the variable we are differentiating with respect to. I mean, if we have f of x equals x something, well, that'll be like x. I mean, x will be the variable we're differentiating with respect to. Gotcha. dy dt equals dy dx times dx dt. So in other words, we're saying differentiating y with respect to t equals differentiating y with respect to x times differentiating x with respect to t. I see. So if we were to differentiate y, let's see, what will we get? Oh yeah, and since y is sine of 2t, so 2t, we're going to get cosine, 2 cosine of 2t, something like that. Yeah, I mean, we have that. Why do we have to say it's dy dx times dx dt? What's dy dx? I mean, I think we're going to have to multiply. No, I have no idea what we're doing here. Oh, sorry, using the chain rule. That's okay. Yeah, that's one thing I forgot. Y is a function of t. Y of t equals g of t. That's right. So we do uh the derivative. Okay, here. In fact, I believe I should write this down. So we have yeah, we have our parametric equations. X equals f of t and y equals g of t. And then, okay, so wait, but what are we solving for though? Are we solving for, yeah, it looks like we're solving for y. So yeah, by the chain rule, yeah, so in other words, this is going to be, hold on, let's rewrite that. So this is x of t equals f of t. And this is basically y of t equals g of t. So if we're going to take the derivative of y, or of y of t, y prime of t equals, well, hold on. What's y prime of t? That's the thing, isn't it? It's, hold on. How do you do implicit differentiation? How does that work? Um, what? Well, I mean, let's see. Let's see. Hold on. Oh, search it up for a second. Yeah. Okay. Right. If an equation was in terms of x, so if we had something like x squared plus y squared equals 1, obviously y will be in terms of x. So we will have, and if we take the derivative of that equation, then I believe we get something like the derivative of x squared, which is 2x, because x is the variable we're differentiating with respect to, plus, then we have y squared, but y squared is basically y of x. So we do the derivative of the inner function, 2x, times the derivative of the outer function. No, I'm sorry. The derivative of the inner function, which is 1, times 2y. That's what we get. Gotcha. Okay. I think we are remembering. We are remembering how it's going. So if we go back here, let's see. So y is a function in terms of t. Um, so the derivative of the outer function. What in the world is that? That's going to be, oh, in fact, yeah. So the derivative of y, that is dy with respect to t, dt. And then, um, what does that equal? So that's gonna but why with respect to x though? I'm confused. All right, the derivative of y prime of t. That's gonna be derivative of the inner function t prime times y of t prime. That's equal to, and what's t? Well, it looks like t is 1. So yo, hold your horses. Hold on. We also, oh my gosh, this is also sine 2t. This is sine of t. So this is going to be t prime times y of t prime. So that's going to be equal to the derivative of 2t times the derivative of sine, well, yeah, sine of 2t, which equals to 2 times, well, yeah, the derivative of the outer function. What's that? Cosine of 2t. 2 cosine of 2t. All right, I don't think we did anything there, but okay. Wait, why dy dx? This guy's just yapping stuff. Why dy dx? We're gonna, oh, yeah, right, right. Okay. Oh, that's okay, 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 okay. So he's actually making a very good point. So I'm just gonna erase what we did here. We want, okay, my handwriting is horrible. What do we want to find? We want to find dy dx. Oh, so there you go. We want dy dx. So we know, uh, for example, dy dt, we can represent that as dy dx times dx dt, right? Right, the dx is cancel. So solving for dy dt, sorry, dy dx, dy dx equals dy dt, whoops, dy dt over dx dt. This equals to dy dt times dt dx, yo, that's dy. And that equals to, well, what in the world? Yeah, that's dy. Guys, I don't even know. Right. Why am I stop? Of course, of course. Yeah, considering if dx dt is not 0. Right. Right. Oh, so dy dx equals dy dt over dx dt. That's correct. Hold on, a horizontal tangent. What's that? I mean, I know I should know this, but I mean, I might just need a reminder. So we have, what do we have? Dx dt and dy dt. Oh, gotcha. My bad. So considering, in fact, here, that's what I'm going to do at notes. So we have x equals sine of t, y equals sine of 2t, and remembering that dy dt equals, whoops, no, sorry, that's not what we want. Remembering that dy dx equals dy dt over dx dt. Well, hold on, this d. Remembering that this is the case, we see that. So what's the derivative of y equals sine of 2t with respect to t? So we get 2 cosine of 2t over, and then dx dt. Hold on, what time is it? It's 5:24. We're good. And dx dt. What's dx dt? Well, applying the derivative of 2x equals sine of t. And that's going to be, what's that going to be? Cosine of t. Yeah, that's pretty much what we get. Yes, ma'am. That's right. Very interesting. Horizontal tangents exist when dy dx, just, yeah, the slope is 0. That's right. How could I not have remembered that? Yo. Oh, well, when will that happen? When dy dx is infinity? I believe so. I believe that's the case, and I think I have the correct intuition. Yo, what? Future U.S. President David Ninja King? Yes, sir. I'll serve you well. Oh, for sure. Oh, Nico. Oh, bro, what's up? It's very good to see you here again. Oh man, it's so nice to have you here in the stream. At least I hope you're watching. I mean, like, oh, maybe you're not watching actually. I don't know. Well, it's okay. Well, I mean, hey, bro, it's really good to have you here. And I don't think I've met you before, but also thank you very much for being in the stream. Yeah, dude, it's very good to have you here. Anyways, let's go back. Let's go back. Hold on. So, hold on. So dy dx. Oh, right. That means this. So dy dx is 0 when dy dt. Whoops. No, the logic is consistent here. Dy dt over dx dt equals 0. And that implies that dy dt must be 0. That makes so much sense. So this implies that horizontal tangents exist when, hold on, how long are we into the live stream? We're 26 minutes. We go 26 minutes. So that's a reminder to where to look at when we're trying to remember what I learned. Exist when, hold on. When what's, when dy dt equals 0 or 2 cosine of 2t equals 0. Oh, gotcha. And the variable we have is inside. We have a 2t. So cosine of what is 0? When whatever inside cosine is 1, I believe. So that means that implies that t must equal 1/2. Undefined. I said infinity, but I believe undefined is exactly the same thing. Let's go. I love that. I love that so much. In fact, I'm going to erase all of that. I'm going to move all of this down here. And then I'm going to say, let's put some color. Do you guys think we should put some color? I'm going to put some color. Well, and in fact, I'm going to trace over here 2 cosine of 2t. That looks a little ugly, actually. Every night I lie in bed, the brightest colors fill my head. A million dreams. Oh, okay, hold on. Wait, no. I get it. A million dreams are keeping me awake. Very good. Yo, Spot on. Spot on. I love that. All right, hold on. Let's go back to blue. That means when that means when dude, stop. Why? When is cosine of t undefined? That'll be when like t equals infinity, I believe. Yeah. Right. Yo, what? What? What's cosine? Oh, right. It's not cosine of 1. Yeah, that makes no sense. That'll be cosine of pi halves. Oh, and pi halves is found when, hold on. Pi halves, that'll just be pi, but I don't want that. I want pi halves. So we want pi over 4. Dude, what is going on? Is that what you got? No, you got pi. Oh, right. Let's go. Yes. Wait, what? The vertical tangent equals to 0, but that's. Hold on, hold on. Was bro, what? Oh, I get it, I get it, I get it, I get it. Oh, no, 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 sorry. That's good. But that means that implies, bro, stop. What are you doing? But that implies that dx, dude, stop. What are you doing? Dx dt is 0. The logic makes sense. That implies that cosine of t equals 0. And therefore, when is cosine of t? When is cosine of t equal to 0? Cosine of 0 is 1. Cosine of pi over 2 is 0. Wait, hold on. Wait, what? Sorry, I wasn't. That makes so much sense. That's actually super cool. Okay, that's actually super cool. Um, gotcha. So let's do this problem. Can we do it? So here's what's going on. Let's give some context. So we need to find the equation of the line tangent to the parametric curve. And they're giving me a picture right here. It's like a bow, or it's like 2 ears and then 2 lines or something like that. T equals 4. Gotcha. And I have x equals t to the third minus 16t, and y equals 16t squared minus t to the power of 4. Well, I think this is pretty easy, right? So, in fact, let's draw this thing out. What? That graph is huge. But all right, let's do it. So we have, sorry, we have black. But before that, we just want to clean our iPad. There we go. That's so good. Yes, yes. 637. I think we're doing good, but what? What's going on here? Yo, we got distracted. I can't do that. Hold on, where was I? So we had a graph. That's a little bit ugly. Then we have um, here. Let's draw our graph again. Do you guys like my graph? I think it looks beautiful. Whoops. Gotcha. So we have these four, and then we need to find the equation of the tangent line to the parametric curve at t equals 4. 4. Huh. Let's see. Well, I believe what we're going to do at t equals 4, that's, let's see. So we know that dy dx equals dx dt. Wait, hold on. dt dy, sorry, dt dx. Wait, whoops, no, sorry. dy dt over dx dt. Right. So if t equals 4, okay, here, let's see what he does. Oh, gotcha. No. Oh, fear. Okay. So our point, t equals 4, right? So, let's see. So 4 cubed, 64, and minus 16 times 4, 64. So that's 0. And then y of 4, that's going to be, so 4 squared, that's 16. 16 times 16, that's 256. Minus 4 to the power 4, which is also 256. So that's also 0. What a coincidence. So at t equals 4, we have 0, comma 0. Then our derivatives dy dx. Hold on, in fact, I'm going to put it on top. dy dx. Bro, stop. Sorry. dy dt. What does that equal? That equals what? 32t minus 4t cubed and dx dt. That equals 3t squared minus 16. So, dividing those equations, guys, this is algebra. This is middle school algebra, guys. Or high school, I don't know. Let's see. So, should we factor? Should we factor anything? Let's see. Yeah, that looks a little bit tough. But I think we're on the right track. Let's see what he does. Yeah. Bro's just reading off the slides. On the slope. Yo, pause. We forgot. Then when t equals 4, that implies that. Yo, negative? Oh, wait, negative, right? Yeah, negative. 4, 64, 256. And then we have 16. 48 minus 16. 32 minus 256. 254, 224. To negative 224 over 32. Here, okay. In fact, we can do this ourselves. 224 over 32. So we have 160, 192, 192, 194. Oh, awesome. Convenient. We get -7. I believe that's. Is it really this easy? Because, wait, how did you get -4? Well, why did you get -4? Wait, oh my gosh. I mistook that for an addition sign rather than an actual variable t. So we have 32t, or 32 times 4, 160, 128 minus 256 over 32. -128 over 32 equals -4. Yeah, this is actually not bad. If you paid attention to Calc 1, then I think you're good. Yeah, 0, comma 0. Oh, so that means at 0, comma 0, the slope is -4. Oh, in fact, I love the way he organized it. It's actually so hot. So, I'm spitting in my iPad. David, why? David, stop. Why am I spitting in my iPad? Hold on. Find slope. I love that. Fact, we're going to put a border. Um, I love this. I mean, it makes a lot of sense. Mm. Oh, yo, we still need the equation though. So we have y equals mx plus b. Wait, we can also use point slope form, but okay. Um, y equals -4 x, and the y-intercept, well, that's 0. Plus 0 equals y equals -4x. All right, I believe we are ready to begin our homework, and that's why I'm going to live stream. Sorry, I'm going to share my screen. Hold on. Yeah. Hold on. I have one question. Do I have Slither.io? Yeah, no, I don't think I do. Let's begin the homework. How many questions do we have? Oh, we have 12. Let's go. Not as much as, I don't know, 35 or something like we had last time. Yes. All right. You know what? Right before, I believe it is time to play a little game of Gold per IO. Okay, well, that's fun. That was a lot of fun. But it's time to focus. Mm-hmm. Wait. Right, right. Function of t, okay? Well, I believe that's your answer. That was pretty easy. Yo, maybe we can knock this out in 30 minutes? It won't be that hard then. Gotcha. Find the equation of for the line tangent to the parametric curve x equals t cubed minus 25t and y, oh, x, yeah, and y equals 25t squared minus t to the fourth at the points where t equals 5 and t equals negative 5. For t equals, oh, okay, at those points. Um, an equation of the line tangent, gotcha. Very easy, very easy. So first, let's find our slope. Mm-hmm. And dy dt. Very good. And dx dy, or in fact, we want dy dx. And this at the point 5, or actually negative 5 first. Very good, very easy. 50 times negative 5, well, that's going to be what? Negative 250. And negative 5 to the third, negative 125. So that's plus. Negative 125 times 4, 500. And then negative 5 squared, that's 25. 3 times 25, 75. 75 minus 25, 50. So in other words, we have 250 over 50, that's 5. So here we get 5x plus b. And what's b in this case? Well, let's find the y-intercept. Oh, whoops, sorry, this doesn't belong there. Negative 5. Here, we'll find b later. Let's just do the, oh, and then here we are. 5. 5 cubed. All right, so now let's find b. Oh, well, I guess we're gonna have to do this. Hold on. Let's find out. Okay. Why am I talking? I got to stop yapping, you know. Okay. Let's see. When do the equations wait? B is the y-intercept. So in fact, I want y. When does this equal 0? So if t equals 1, we have 25 minus 1. If t equals 2, we have 100 minus 16. If t equals, let's say, 4, yeah, no, that wouldn't work either. If we have t equals, I don't know, like 10. All right, let's just go to Desmos. Yo, 5. 5 is our intercept. Yo, excuse me? Constant term. Oh my gosh, my bad. All right, well, that's still wrong, but I believe we fixed our constant terms. Wait, pause. Hold on. No. There you go. Sorry. Hold on. So for the y-intercept, when does the equation, hold on, what values of x? All right, I'm just gonna put this again. Oh, oh, is it like -5 or? Yeah, I've never been good at tangent lines. Sorry, y-intercepts. Oh. Oh, crosses the y-axis. My bad. So that is x equals 0. Oh. Oh. Hold on. So let's see. If I have wait, what? For real? Crosses the y-axis. Oh, right. No. That's good. Everywhere you are. Oh. Bro. Okay, hold on. So right, we need to know a point. So mm, so 5 cubed is 125. Oh, that's 0. Oh, gotcha. Okay. Everywhere. Or is it the other way around? Hold on. Oops. Yo, bro. All right, at t equals 5. Two. Oh, what? Why at 0? I'm confused. So, like, what value of t does the equation cross the y-intercept, the y-axis? It looks like it. Oh, let's go. 2 people are watching. All right, let's keep going. So, find dy dx expressed as a function of t. Gosh, I have something in my throat, bro. What's going on? For the given parametric equations. So, what's dy dx? So, sorry, dy dx. So dy dt. One over t, and then apply that dx dt. 6 minus 1 over t. Dy dx is dy dt over dx dt. That equals to 3. Oh, whoops, hold on. dy. Bro, what in the world? There we go. That's dx and that's dy. Cool. So the 6 minus 1 over t over 3 plus 1 over t. Go t. All right. That's, hold on. Yeah, that's literally it. 3 plus. Find, hold on, what's that? Oh, no, the double derivative. Gotcha. So I believe, hold on, so these questions are easy. Why am I spending too much time on this? Oh, wait, yeah, whoops, you don't put the parentheses, right. That's only until you reach 4. That's going to be, well, we basically have t to the negative 1, so we have t to the negative 2 equals negative 1 over t squared. And I think the same applies to that, except we get 1 over t squared. So here we get negative, hold on, that's x. We need y. So 1 over t squared over negative 1 over t squared. Compare negative, and what's this? Is that 1? So probably negative 1 will work, right? And what happened here? Did we find the correct derivative? Hold on. T to the negative 1. That's, and the derivative of that, that's negative t to the power of negative 2. And that's 1 over, or negative 1 over t squared. And that's x. Hold on, so yeah, let's remove that. Let's just put that there for a second. Then we have the derivative of 6 minus 1 over t. And the derivative of that is going to be negative, or yeah, now we have negative t to the negative 1. So that's t to the negative 2. Then that's 1 over t squared. That's correct. What's going on here? What did we do wrong? I feel like the mistake is very obvious. Hold on. Don't. Okay. D of dy dx. Did we cover this in the video? Because I don't think I watched it all. Oh, wait. Oh, we're concave up and concave down and that kind of stuff. Are we going to do that? Highs. Well, it doesn't look like we covered the second derivative. I'm just going to go back to where I was. I believe I was around there. Yeah, it doesn't look like we're doing another derivative. Whoops. So is it here? It's okay. Here, this looks important, so I'm going to get some help. Correct. To find the second derivative for part B, can you use the fact that dy prime dx? Hold on, wait, are they asking me? Yeah, no, they're also doing for the bottom as well. Notice that dy prime dt can be computed using the quotient rule. hold on. So, hold on. First of all, what's y? Y, oh, yeah, y is 6t plus ln of t, and the derivative of that, that's t plus 1 over t. What? T, right, yeah, t plus 1 over t. So now the derivative of t plus 1 over t, that's 1 plus, or 1 minus 1 over t squared. No, we're not doing that correctly, are we? We are not doing that correctly, are we? Oh, interesting. Hold on. 6 plus 1 over t. So we're simply, hold on, wait. What do we want? We want dy prime over dt. That's what we want. So we basically take the derivative of dy dt, right? That appears, wait, but why do we need the quotient rule though? And what? Why are we taking the derivative of dy dx? Oh, wait, no, I get it. Hold on, cool. So what do we want? We want, what do we want? So we want the derivative of dy over dx. Oh, no, gotcha. I get it. Hold on. So basically, so we can screw that. Wait, is that 3 plus? That's 3 plus. The derivative of that. Yeah, right, yeah. So what's that? Okay, now we're using the quotient rule. So f prime. So that's going to be 1 over t squared times 3 plus. Bro, why isn't this working? Do I need another? No, that should be working, right? Yeah. Yeah, I guess that's it. T squared as well. Huh. Wait, yo. All right. What in the world is going on? Notice that dy prime can be computed using the quotient rule. Now, what in the world is dy prime? So we're taking the derivative of 7 minus 1 over t. Taking the derivative of the fraction dy dx. We found earlier. Wait, what's the relationship between dy dx and dy dt? Oh, so do we like multiply by dx dt both sides or what? Hold on. So what in the world are we taking the derivative of? So we have the derivative of the upper function. Oh my gosh, what in the world are you guys? How did you guys get that? Where do they get 6t plus 1? Are they taking like an integral or what? All right, I'm actually confused. We go 1 hour and 17 minutes. It's actually not a long time. Hold on. It's 7:19. Let's see. Come on, this shouldn't be this hard. So using this formula right there, what's dy prime? So I would take the derivative of 7 minus 1 over t. And let's just ask ChatGPT and make sure that we're doing this correctly. Right, so now we're close to 6t plus 1. Oh, they multiplied it by t? Gotcha. Why would they do that though? Oh, wait, yo, I'm sorry, what? This is actually pretty interesting what they're doing here. I think I see what they're doing. Gotcha. So they have the dy prime dx equals dy prime over dt over dx over dt. And to find dy prime over dt, well, you can simply okay, fine. Yeah, you can multiply dx dt both sides. So if you do that, you get dy prime over dt isolated, and therefore you get dy prime over dt. And what in the world is dy prime over dt? Bro, I don't want to be stuck in this question so long. Dude, I only have so much brain power, okay? Hold on. Stop. So let's write that down. God is great. Give him all the praise. Hallelujah, name above all names. Fire in his eyes, healing in his veins. Everywhere is glory on display. Take a look at those stars, you can name them all. Every knee falls, demons have to run, the angels have to praise. Our God is an awesome God, he reigns from heaven above with his own power and love. Our God is an awesome God. Our God is an awesome God, he reigns from heaven above with his own power and love. Hold on, so wait, hold on. Derivative of dy dx. I mean, that's what we have here. Wait, and what was the derivative of dy dx? Oh, wait, okay, well, yeah, taking the derivative of that fraction. I have one question, though. I have a feeling this is true, but I just want to make sure. Mm-hmm. They're exactly the same thing, so that's very telling. Oh, God is great. Give him all the praise. Hallelujah, name above all names. There we go. That looks much better. Oh. Wait, what was dx dt? Gotcha. Yeah. So using the quotient rule over here, we get still wrong. Dy dt. Well, that'll be 6. Bro, what? Dude, I'm so what? Dude, what are they yapping about? What in the world? Correct. So we can use that. Okay, I see, I see. Um, dy dx equals dy dt dx dt. Dy dt over dx dt. And by taking the derivative of that, we get our quotient rule. Oh my gosh, bro, what in the world am I doing? Why did I multiply? All right, so, okay, hold on. So we have, what's the derivative of that? That's 6. And what is dx dt? 3 plus 1 over t. Or 3t plus 1. Bro. Oh, why? Okay. Want that? Bro, what's the difference? That's the same thing. All right, let's keep going. I think we understood, but they had a complicated, like, I don't know why they complicate things like this. Oh, hello, how are you? What is the video about? Well, this live stream is just about me doing my calculus homework and kind of rage quitting sometimes, but then going back because I need to finish my homework. So if you want to see me do my homework and get frustrated over some problems, then you're at the right place. I was kidding. Oh yeah, kind of. I mean, yeah, I'm just doing some calculus 2 homework. It's we're doing some parametric curves right now. So for example, here I need to calculate the parametric curve of x equals 49 minus t squared and y equals t cubed minus 9t, at which value or values of t is the tangent line to this curve vertical. Oh, very easy. Well, we know that dy dx equals to dy dt over dx dt. That means for a vertical, that means for the tangent line to be vertical, dy dx must be vertical, and therefore dx dt must be undefined. Must be 0. So taking the derivative of x, hence getting dx dt. Bro, that looks like an O. We get like what? Negative 2t. There you go. That's what we get. So what values of t is at 0? Well, 0. Write the point or points at which the tangent is vertical. Good question. Let's see. Hold on. If I go back 2 questions, what was the value that they gave me? Oh, it was just at a certain point. So There we go. Whoops. So what is x of 0 and y of 0? 9, comma, what was it, 0? I think. Hold on. T cubed 0 minus, 0. Is that what they want us to do? All right, horizontal, that means when dy dt is 0. Whoops. T is square root of 3. And negative a square root of 3. And then zero, I think. There you go. And then there you go, 46. So in this case, it would be still 0. Gotcha. Oh, and we need to graph our stuff. Oh? So let's think about this. What did we say was when the tangent line was vertical? And I said a t equals 0. Vertical. Yeah, that seems about right. And then horizontal, I said from square root of 3. Hold on. Bro, I keep hitting the wrong button. Right there, and then right there. Perfect. That's good. Okay. Oh, wow. Very close. Whoops, that is 3 square root of 3. Hmm. Well, the x is negative. Oh, at which t values? Bro, oh my gosh. So negative 3 and 3. And these are the t values that worked. Mm. Oh, so it gave the same result. Oh, gotcha. Hold on, hold on. So I think this is correct, but we're not done yet. Bro, what in the world? Bro, I don't know. I don't know, dude. I don't know what to do. Oh my gosh, bro. What in the world is going on? What substitution am I doing? All right. What is it? 46. Uh, bro. Yeah, dude. I officially have no idea what I'm doing. Right, pause. Hold on. So, all right, let's do just that. Oh, wait, for real? Is it just that? Is it negative? Finally. Well, I'm gonna go to the bathroom, dude. Oh. Oh boy. Well, I'm gonna take a teeny tiny break by playing some Slither.io. Oh. Da 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 da. Mhm. 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 Yo, what? Okay, I believe it's time. Oh, hold on. What's new here? Amen. Anyways, we're not done. We're only 33% of the way there. I'm tired, guys. But if I want to live in this house, I got to work hard and do what I have to do. Okay. What else questions? What other questions do we have? Oh boy. Okay, we have some multiple choice. Looks pretty easy. All right, those last questions don't look too hard. Oh. All right, let's do this. Delta is 62. Oh, right. I have to divide by 6. So dumb. Crap. All right. Well, that changes everything. Oh, that's still not correct. Oh, wait. Hold on, hold on. Wait, X and Y? Wait, what? How do you do this properly? There's no way I can do all that algebra. How? Oh my gosh, bro. Whoops, sorry. I can't give the wrong equation. It was Oh, bro, I'm so dumb. Hold on, hold on. Oh, come on, dude. That was dumb. I literally mistook them. Okay, well, this is correct. Perfect. So now, now we have 0 and -1. So for 0, we, hold on, by the way, I want the derivatives. I don't want the actual functions. X minus 12. Okay. -12 and then 0. And then we have -1 and the same thing. Yeah, that's the derivative, right? Yeah. Unless I'm factoring incorrectly. Yeah, t0 and t-1, right. So wait, no, hold on. Wait, bro, what? No, I just want the actual equations. T and then +1. There we go. Wait, what? Zero and 7. And then -1. 12 and 13. Bro. X, Y. Oh my gosh, hold on. Bro, I forgot to. There we go. So for t equals 0, we get 0. 0. Yeah, I already had that. 1. 13, and then 2. Oh boy. Let's see what's going on. Oh my gosh, hold on. No, I want, oh, what? I want to make the derivative 0. Right, I already have those points. Those are 0 and -1. And then we need to put them back into the original equation. Am I even doing the right equation? Yeah. So what in the world is going on? X is with a -12, right? 0, 1. Bro. Oh, wait. So this is, how about that? Oh, actually, all of these are in because here's the thing. I think I understand now. For the same t values that made the tangent line horizontal, it also made them vertical, but they can't. But when we have 0 divided by something, it'll always be 0, regardless what the denominator is. So even though the denominator here also could have been 0, making the fraction of derivatives to infinity, the numerator, all those cases, and in all those cases, the numerator was also 0. So we would have never had, a case where the derivative of the functions is undefined. Dude, what? That's oh, yo, 6, 7. Guys, we found 6, 7 again. What's going on? Zero and -1. Or what? Do you want me to put? Oh, okay. I really hope this is not the case. Yeah, okay, phew, it's not. Dude, I don't know what to do. Oh, smallest values of x. What about 2 there? What about 0? Yeah, bro, I don't know. Yeah, bro, I don't know what to do. Bro, I'm still in question 5. Oh my gosh. This is so annoying. Bro. Wait, okay. I don't. Wait, why -2 though? Oh, hold on. Oh, no, I did it again. Bro, no way. Dude, no way I actually did that. Really? Yeah, whatever, bro. So we get 20 and -3. And what's the other point? We have 1. -7 and 6. That's not funny at all. That's not cool. Bro, we had it. We go 2 hours and 28 minutes, guys. I'm kind of tired, and we're not even halfway. But here, these questions look a little easier. How do you find the highest and lowest point? Oh, hold on. I'll be right back. I will be right back. All right, we're back. We're back, y'all. I had some good stuff. Cool. Is that the same question? Are they very similar? Hold on. So the highest. Right. Excuse me. Oh, gotcha. Of course. Of course. That makes a lot of sense. In fact, that makes beautiful sense. That's so cool. So using the product rule.
Whoops, that's t.
Mm.
So that means, let's see. So when t equals 1, horizontal, the derivative is 0, and thus the slope is horizontal. And at t equals -1, the derivative is undefined, and thus the slope is vertical. So to find the highest point, we've got to find when the slope is 0. So yeah. So at t equals 1, 3e. Gotcha. Wait. Is it a point? Oh, gotcha. A horizontal asymptote. What's a horizontal asymptote? Oh, as x tends to infinity. Hold on, I wanna. So. Da da da. Oh, let's go. Oh, we got this correct. Oh, wait, leftmost? Oh, I thought that was a.
Oh, a vertical, right. Oh, bro. How do you find the horizontal asymptote? Um, Still streaming. Yes. Yes, unfortunately I am. Unfortunately, I'm still streaming to get the homework done. I know, but you got to do what you got to do, right? Horizontal asymptote. As x tends to infinity, what does y tend to? Zero. Infinity? Oh? But this is for the x, though. All right, as t tends to infinity. 3 times infinity. Yeah, that's infinity. Um, oh, hold on. Here. Let's graph them. So, as t tends to infinity here, what does this tend to? Bro, stop. What is the value, though? What is it, like 10? Is it 9? Bro, how do you find that vertical asymptote? Yo, what? Alrighty then. Okay, let's go. All right. Here now we're up. Now we're in Brooklyn. Oh, okay. Let's do this. Right. Oh. Okay. Here. Okay. Okay. Oh, I see. Right.
boy. Well, according to here, wait, let's see, dx dt. What's dx dt? So we have 1 plus or 1 minus sine of t. So the integral from 0 to 2 pi of 1 minus sine of t, all that squared. Whoa, where am I? What? Bro. Which, oh, sorry, I'm right here. Plus dy dt. Excuse me. 1 minus cosine of t. Oh, wait, whoops. Again, dx dt. Bro, what? Oh, no. We're good, we're good. How did we get a 2? Should we expand that? I don't see any sine squared in here. Yo, what's going on? Here, let's try to expand it out. How long do we go in the live stream? We go 2 hours and 55 minutes, bro. It's crazy. Oh, could we use the... Wait, is that also squared? Bro, that's also squared. What am I doing? Of course, and we can use some trigonometric identities. Plus cosine squared of t. Very good. 2 oh, and then another plus 1, right? So that's 3 minus 2 sine of t. Oh no, I'll go back. Minus 2 cosine of t. Very good. I'm so proud of myself for doing that. Oh, that looks good. Yo, that was so cool. That was actually super cool. Let's go. Let's go. Oh ho. Oh ho. Oh ho. Jehovah. Hold on, so we have 5 questions left. Oh boy. Mhm. Which of the following integrals represents the length of the parametric curve x? Yo, why does my iPad look like hell? All right, that's a strong word. Yo, so we go 3 hours live streaming. It's fine. I think our record was like 4 hours and 50 minutes or something, almost 5 hours. All right, well, we have x equals the natural logarithm of t, y equals square root of t plus 1, where t is in between 1 and 5 inclusive. So this would be from an integral from 1 to 5. Oh, hold on, wait, does it still look bad? No, that's okay. So here, let's understand this well. Of dx dt squared. Very good. Oh ho. Oh ho. All right, and dx dt is 1 over t. Let's go. And dy dt is 1 half t plus 1 negative 1 half times 1. That's simply 1 half times 1 over square root of t plus 1. And that is just simply 1 over 2 times square root of t plus 1. Mm-hmm. 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 Oh, oh. Mm-hmm. Oh, oh. Mm-hmm. Mm-hmm. All right. Mm-hmm. Mm-hmm. Could it be that one? All right. So that's wrong. Mm-hmm. Back to the table. Hold on. Did I even do the derivative correctly? Derivative of, this should be super easy. Like, I got 1 over 2 times square root. Okay, cool. And yeah, I'm not even gonna ask that because we should know that just like my instinct, ow, that hurts. So let's see. Back to the table. Back to my home. Yo, we are not multiplying, we're adding. Back to my father. Look, oh, gotcha. I see. We're cross multiplying. Gotcha. We have a t squared. It looks like we're going to factor. What adds to 4 and multiplies to 1? Yo, should be 4. 2 and 2, right? Back to the table. Yeah, no, I don't think we can do that. Back to my home. Oh, what if we just divide it by 4? Back to my father. Yo, what happened? Yeah, so we divide by 4, both sides. We get yeah, but I don't think that's really good. Oh, wait, are we actually applying the square roots? Okay. I see what we're trying to do. Hmm. 4t plus 4. 4t cubed plus 4t squared. Right. Okay, that looks good. So let's factor. Bro, how do you want me to do this? Okay, that could probably be it. Well, I should get something like t. Yeah, I'm just so dumb. But from 1 to 5, gotcha. Cool. Oh, x plus 2. Okay. Back to the table. Back to my home. Back to my father. Who's never letting. Oh wait, hold on. We can factor 2. Who's never letting go? Yo, stop. All right, is either one of these. Either one of these three. Looks like we have a 2. Oh, and we can also factor a 2t. Not just a 2. There we go. Or in fact, let's factor a 2. Oh yeah, right. 2t and just t plus 1. Let's go. Let's go, my friends. I'm telling you. LARP, 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 Sahur. Oh, huh. Tongue, tongue, tongue. Tongue, tongue, tongue. Sahur. That's funny. Yo, how did I do that? How did I put like a Chinese character? That's crazy. All right, guys, we have 4 questions left, and we in our live stream has been going for 3 hours now. Kind of tired, but we're doing well. In fact, I think we're doing super well. I'm proud of what we're doing. Back to the table, back to my home. Yo, stop. Back to my father. I'm not even sure that's what it says. I'm just seeming at it. Find the length of the parametric curve of the parametric curve. Well, first, cool. Let's do so. The integral from 0 to 4 of the square roots dx dt is 12t. dy dt is also 12t. Oh, whoops. But this word, gotta be careful with that. So what's killing Thompson sent to vote? Let's go. I hope he voted for June. Hold on. 144. DT. I believe we can't factor. Is that for real? We're joking right now, right? That's not even funny. Da-da-da-dee-dee-dee-dee-doo. Doo-doo-doo-doo-dee-doo. Tong, 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 sahur. Yo, so, all right, now we just need to solve this integral. Let's do it. We have, we have like a product of functions. Do we do u sub? No, that's for the chain rule. Oh, of course, integration by parts. So what is u? U is 12, obviously, 12t, and v is the square root of 1 plus t squared. Sorry, dv. So the integral of u dv equals to u v minus integral of v du. So the integral from 0 to 4. Oh, yep, great, definite. No, it's okay, cool. 12t from the square root of 1 plus x squared t squared dt equals to 12t. Oh, wait. Oh, hold on. Du is 12, and v, well, that's the integral of the square root of 1 plus t squared. Oh boy. And the derivative of t squared is 2t, so over 2t. Wait, whoops. Wait, yo, what? How do you get that? Fine. I mean, I should know this. I don't know why. It's very time consuming. Oh, right. U sub. U sub. Wait, sorry, D. You know what? That's it. Am I supposed to solve that integral?
Yeah, I mean, evaluating the integral is a little bit tough. Okay. Yeah, I should practice evaluating that integral. But I believe that's for another time. Okay, what happened? Oh, wait, whoops, square root of 17. Still did not work. Wait, whoops. There you go. Gotcha. What? Square root of 17, 96. Oh, yeah, ln. 4 plus square root of 17. Bro, it's getting late. It's like 9:22. How long have we been going? 3 hours and 19 minutes. Hold on, wait, dude, I can just do this in Desmos. You guys believe that? Wait, did I even put it correctly? All right, let's just put that. Still wrong? You got 104.29. Bro. Oh, maybe I set up the integral wrong. Oh, that's different? Oh my gosh, hold on. I'm not adding anything. There we go. That's better. Or not? Oh, bro. T. There we go. I mean, the important thing is that I understand the concept. Yeah. We have 3 questions left, bro. Oh my gosh. What is up here? Oh boy. Hold on. Before I finish these last 3 problems. Alrighty. I believe it's time to continue and finish this homework. In fact, what if I just do this? Hold on. What if I do the integral 0 to 7/6 pi of the square root of the derivative fact, all of this, the derivative of 8 cosine of theta plus theta sine of theta. What? Yeah, plus so is it 0? It's not 0. What did we do wrong? So we have, for the y, 8 sine of theta, theta cosine of theta. And that's minus. And in the other one, we have plus.
Sine of theta, theta, sine of theta. And y isn't. Bro, why is... Right, that's what we did. Wait. Yeah. Why is this wrong? That looks completely good to me. Hold on. Why is that? Why is that 0? Yo, what? Eight theta cosine of theta. Yeah, 8 theta sine of theta, right. Wait, whoops, this is d theta. Oh, no wonder that happened. Har, 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 har. Yep, all right. Oh, we have 2 questions left. Wait, we don't have 3? Oh, let's go. Oh, Lord, how majestic is your name. To find the area that encloses it, are we using... Oh, Yo, 3 people are watching. Let's go. That encloses it. Are we going to use... Hold on. Da, 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 da.
Oh, and that's 0? So is this one actually 0? No, that's an area. Like, I don't think that would be 0. And I mean, I know that I'm not doing the same mistake as last time. I mean, I have d theta. Let's see what happened. Hold on. What are we even? Oh wait, g of t. Hold on. Oh, so it's simply 6 sine of theta. There you go. Oh wait, hold on. So this is six sine of t. And then we have the derivative of f of x, or f of t. Where is it? Oh, reverse endpoints. Yeah, so I guess if we simplify, we get negative 42. Oh, we don't have that. Yeah, that basically just canceled out. And I guess that's our answer. That's not. Hold on, why not? No, well, yeah, I guess I could just do now. The same thing. Yep. Yes, because we can use trigonometric identities. 1 minus cosine of 2t, I believe. Wait, and that's different? Why? I'm gonna hold on. So I have x equals 1 minus cosine of 2t. That's not the same, bro. Wait, so how do you do that then? Bro, that's so okay. All right. We're using the same equation. All right. Back here. From 0 all the way to. Oh, gotcha. So what does that mean? 0 all the way to 5/2? The derivative of x. Okay, hold on. So first we have g. Okay. And the derivative of t minus 1 over t. 1. Bro, why do they have to do this? One plus 1 over t squared. Okay. Yeah, so in this case we'd have what? Yeah, right, 5 over 2. We need to solve for t. Oh, what? Oh, right. Top minus the bottom.
Yeah, considering that we're not touching any of the axis. Uh-huh. Well, right. I mean, if it's a 5/2, that's not the axis. So really, we'd have, yeah, we would have that. How do you define what's the top and the bottom again? Oh, we were actually very close. Hold on. Yeah. So we had what, 5/2. What's our derivative? 1 plus 1 over t squared t. All right. If this doesn't work, we just need to simplify. Cool. Looks like we need to simplify. Right. Hold on. All right. Well, yeah. I guess if we just expand, we get here. Let me just take that. Oh, cool. So x plus 1 over x plus 1 over x plus 1 over x cubed. Okay, that's what we get. Yo, why did it change? What? There you go. So we're moving. There we go. Same thing. Hold on, wait. Where do you get that 3? Oh my gosh, bro, please. It's like 9:50. How long have we been here? We've been here 3 hours and 47 minutes. Yeah, dude, I'm gonna ask, bro. Please. No. There we go. How did he get from the first to the second? Wow. That was spelled horrible. All right, now let's do the completely arbitrary way they did this. So what did you do? Multiply everything by 3t. And why in the world would we do that? Well, looks like that's what they do. So multiply over here everything by 2t. Only get 2.
Oh, so you do get 1/2 and 2. So we were correct. Five halves, bro. Yeah, 1/2 all the way to 2. Wait, do we have to invert it? No, we don't. So we had 5 halves. Whoops, where are we, bro? Hold on. We had 5 halves minus t plus 1 over t. That's g of x times 1 plus 1 over t squared. That's f prime of x. Now, why in the world is this not working? Hold on. I want to see. I want to ask him why this is. Wait, did he even? Why is this not the right integral? I'm confused. Fine. Why isn't the plus plus? Oh, really? Let's see. Yeah, our g of x and our f prime of x. So far, so good, right? Yeah. Five halves. Right, yeah. Hold on. Okay. Right, so we had 1/2 and 2. All right, so right, yeah, our Riemann sum. So what is the correct integral? Difference. All right. I mean, I get that. Yeah, so far so good. We did that. Wait, so without the 5 halves? Like without that? Oh, is that what you meant by difference? By difference times derivative? Hold on. And why 3 halves though? Okay. 2 minus 1/2, 3 halves. Okay, I get it. I get it. Hold on. So that's 3 halves. This would be like negative 3 halves, I'm guessing, because we're subtracting 2. Hold on. Or is that negative 1/2? What do we get? Yeah, negative 3 halves. Wait, what? Hold on. Oh, and then I'm guessing. Okay. Like that? Zip. Yeah, isn't that the correct setup? We subtracted. Bro.
Oh, well, I mean, I'm guessing area can't be negative, so is this positive? All right. Gosh. Well, those last two questions were tough. They're really tough. Oh, guys, I'm about to go to sleep. Hold on. Finally, is this AP Calc? Well, this is a class I'm taking from ASU, so this is like a Calculus 2. It's not directly from high school. Wow, we streamed for 3 hours and 57 minutes. Yo. Oh my gosh, finally. We did it. We did it. But I will for sure have to review that. In fact, I have no idea how I'm going to do for the final exam. How am I supposed to do that entire module in 1 week plus study for everything that I saw in the last 6 weeks for this class? That's crazy. What am I doing with my life? Bro. Oh. I'm probably just going to play a Slither.io game. Okay. Well, everyone, it was super fun doing this live stream, and it was also pretty tiring. So I will see you all later in the next one. Bye-bye.